As far as the park history, it's the first park that was established as a national park in the country. And one of the reasons it was so special was early travelers and explorers passed through it, and they discovered that it had such majestic scenery, and of course the excitement of the erupting geysers and so forth added a lot to the human interest. You only have geyser activity in areas where you have a very high geothermal gradient. And what that means is that as you go down from the surface of the earth down to some depth, the temperature increases, and it increases at a greater rate wherever you have thermal fields, such as Yellowstone. The second thing is you have groundwater below the surface, and the groundwater circulates, and so as it encounters the hot rock, hot material at depth, it heats up. It's basically superheated water, and that's fine as long as the overlying rocks confine it and keep the water at that depth. But if the water starts to rise and expand, pretty soon, because it's under lower pressure now, the boiling temperature is actually lower, but the water in reality is at higher temperature, and so it begins to expand and give off water vapor or gas. And once that starts to happen, it's just an accelerating eruptive process, and so the geysers erupt. When the gas is given off, it's like opening a bottle of carbonated drink that you shake, and so once the gas starts, it really goes. The Yellowstone area, we think, is underlain by hot molten rock, and the evidence for that is the numerous and repeated volcanic eruptions that have occurred there in relatively recent geologic time. That's what the original unusual high source of heat is due to. And the underlying area at the shallow level where you have the groundwater has lots of cracks and fractures and spaces between mineral grains and so forth. So the water can actually migrate slowly through those cracks and joints and fissures and breaks in the rock, and as it circulates downward it heats up, and then as it gets to a certain temperature it wants to come back up. You think of a hot spring as simply just continuous flowing water at the surface. It's the same as if it's a cold spring. So usually it's an intersection of the water table, the top of where the water exists in the ground, with the surface of the earth. For example, if you commonly find springs along the lower part of the valley. That's where the water table intersects the valley. So a hot spring is simply water that's coming out at the surface and not under pressure, and so it simply oozes out or flows out, and nothing exciting is happening. If the water has a lot of sediment in it, and if it also is expelling some of the gas, in other words, the water that is converted to vapor, then this can lead to what is commonly called a boiling mud pot. Sometimes you'll have boiling hot springs that won't have mud in it because there's a shortage of sediment. So if there's a lot of sediment in it, little fine-grained suspended particles of clay and sand and so forth, then that becomes a sort of a boiling mud pot. A geyser, on the other hand, is, as opposed to a spring, only erupts periodically. Some more regular, such as Old Faithful, more or less on the order of about an hour. Some very irregular, and some on with periods of maybe years or many months or something like that. And what happens there is the water in the subsurface is being continuously heated, but instead of having a direct open conduit to the surface, the cracks and fractures that it's going through has restrictions in it. And so the pressure has to build up high enough to drive the water and the steam through those constrictions. And once that happens, then as the water gets to shallower levels, the gas expands and it really truly erupts.
Michael, get out, get out!